Happy quarantine, Mrs. Walton. Today I will be teaching you the root test with ASMR. Mainly because it's like 2 a.m. and my whole house is asleep, and also to get that creative point. Anyways, every 1 minute, I'll be doing a different fun ASMR to show you. All right, let's get started. In order to understand the root test, we need to ask ourselves a few questions. First, how does it work? As you see, the limit as n approaches infinity of the nth root of the absolute value of the series is our equation that you can plug your series into in order to determine your outcome. If the outcome of this equation is less than 1, then the series will converge. If the outcome of this equation is greater than 1, the series diverges. But if the outcome of this series is equal to 1, then your test was inconclusive, and you need to perform further testing. So basically, you plug your series into the equation and solve. It's that simple. Ding, ding, ding. It's been a minute. Let's crumple up some tin foil. Start with our first example, the sum of 3 to the n over 5 to the n from 1 to infinity. As you can see, the equation that I had in the previous slide is equivalent to the limit as n approaches infinity of the absolute value of a sub n to the 1 over n. This is just a different way of writing the equation. I simply made the square root into an exponent. Then I simply plugged in my series for a sub n and distributed the exponent 1 over n to both the numerator and the denominator. I was able to simplify and cancel out both n's because they were being multiplied together. Then my final answer came out to be 3/5. In order to evaluate the outcome of this example, I see that 3/5 is less than 1. Therefore, the sum of 3 to the n over 5 to the n from 1 to infinity converges according to the root test. Let's go ahead and do another example. All right, minute number 2 is through. I'm going to eat these delicious Scooby-Doo snacks. Yummy. Example 2 shows the sum of n to the n over 4 to the 2 plus 2n from 1 to infinity. Let's use the same equation that we've had previously and plug in our series for a sub n, as you see I have done. Next, I will separate out the denominator into 4 squared times 4 to the 2n, which is equivalent to what the denominator was previously, just making it a little simplified and easier to evaluate. Next, I separated the terms in my series containing the n value and those without the n value in order to get 1 over 16 times n to the n over 16 to the n. This will make it easier to evaluate my outcome later on in the problem. All right, minute number 3 is done. So I'm going to tap on this hard surface. Are you ready? Doing that, I was able to pull the 1 over 16 to the outside of my limit. This is equivalent to separating the limit into 2 limits, as if I had the limit as n approaches infinity of 1 over 16, but that simply equals 1/16. So I multiplied 1/16 times the remaining limit, which was what I already had. And I distributed my exponent 1 over n to both the numerator and denominator. Finally, I got an outcome of 1 over 16 times the limit as n approaches infinity of the absolute value of n over 16 by canceling out the n exponents because they were being multiplied together. Now I can determine that this outcome approaches infinity. Therefore, the sum of n to the n over 4 to the 2 plus 2n from 1 to infinity is divergent according to the root test. Finally, minute number 4. I'm gonna rub my hands together. Ooh. Finally, let's make some connections to another test. Here we go. Okay, so the root test is more efficient for a series raised to the nth power. As you saw in the past two problems, let's say our series was x to the n. If you applied the root test, you would simply simplify to get what you were left with. So it simplifies very beautifully. Another attribute the root test shares with other tests is the idea that you're taking the limit of the series as n approaches infinity. The nth term test for divergence, the limit comparison test, and the ratio test all do this as well. Finally, the absolute value in the root test makes the alternating part of an alternating series go away. As you can see to the right, the absolute value of this series simply got rid of the -1 to the n, making it a simpler series to evaluate. Thank you, Mrs. Walton, for enduring all of this cringy behavior. To end our night of learning, I would like to let you know that I hardly ever use Khan Academy, so there's no possible way that this video could have been copied. Also, I would like to end the video with one last ASMR, and it's gonna be a huge clap into the microphone. Are you ready?